Give the acid catalyzed mechanism of the hydrolysis of the ester given below. So we are dealing with an ester, which is a cyclic ester, so which means that it's a lactone, and we're doing hydrolysis of this. Hydrolysis meaning we'll be adding water in presence of an acid, okay, in this one. So the best thing to do first before we do anything else is to see where we are going, okay, what's our goal. So which means what are the products that we will be getting as a result of hydrolysis for this one in presence of acid. So since we have an acid, an ester, and we are adding water to it, okay, we are going to be getting an alcohol and an acid as a result, okay, because that's what esters are formed from. So the important thing is, where do I break bonds, okay, and where is my alcohol? So in case of cyclic compounds, you have to look internally, okay, for this one. So focus on the carbonyl and then break the single bond there, okay, because that's the one where you have formed an internal cyclization to give you an ester, okay. So that's what we will do. So let me go ahead and write that out here. Nothing else has changed, okay. So that oxygen, right now I'm not writing anything else. So that bond that I have broken here, now I have to put something there because of course there's no methyl group there. So what I have to do now is that this is going to be OH because that's the acid, and then this is going to be the alcohol, okay. So that's what I'm going to get as a result of hydrolysis, okay, of this lactone. So that's my goal. Once you have your goal in mind, now we can get started, okay. And also don't forget 1 2 3 4, 1 2 3 4. Don't mess up your carbons, okay. Always count your carbons to make sure that everything is good. So acid mechanism, the first thing that happens, as you know by now, hopefully you're comfortable with this, is that your carbonyl, okay, is going to get protonated. Always start with the carbonyl getting protonated. All right, so that's what happens. And then of course the plus over here. So now we have to add water because this is hydrolysis. So we're going to add water. So we're going to add water to the carbonyl here and relieve that oxonium ion. So we have the OH here, and then we have the water that we just added. Again, another oxonium ion formed over here. So now we are going to have to get rid of this oxygen right here because remember, this is the one that we said is going to give us the alcohol. Okay, this is the one. And also remember, okay, that you have a carbonyl, and the carbonyl oxygen is right here, which is this one right here, okay. So that's not going to go anywhere, okay. That oxygen stays, so leave that. And here I'm doing a shortcut as I've been doing before because I could deprotonate that oxonium ion and then protonate this oxygen. And why am I protonating this oxygen? Because I know I have to break this bond, okay, over here. So that's why I'm protonating that oxygen. But in any case, I'm skipping one step for convenience sake. That's that. And then we have this alcohol here, and now we have an alcohol here also. Okay, so now I need to break this bond, remember? So to break that bond and to relieve that oxonium ion also, I'm going to have to use these electrons. And remember, I'm using this alcohol now because this O I know is the carbonyl one. Okay, so that's why I'm using that oxygen and not the other one, okay, in there. And so then I've broken that bond, so which means that this is what I have. The OH is back here. Now I have oxonium ion and I have the OH. So 1 2 3 4, I haven't added any carbons or lost anything. Now I just need to deprotonate my carbonyl. That's all. So H2O picks up this proton and we are good to go. I'm going to write this as a straight chain so it kind of looks nice. 1 2 3 4 and then OH. Okay, so that's what we have. So take it step by step. Always have your goal in mind. Whenever I'm doing these mechanisms, I write the compound that I need to form, okay? Because if I don't see what I'm forming, then how do I know, okay, where I have to go? So keep those things in mind. Remember, you're also doing hydrolysis. You're adding a molecule of water, okay, over here. So that's it. That's the mechanism for hydrolysis for a lactone.